everybody, and welcome to the show. My name is Nick Larson. Happy Wednesday to everybody. Let's get right into what we're doing today. So, for those of you that don't know, Content Lab, let me make this a little bit bigger here just for a second. Yep, Content Lab, which is backwards because that's how I do the video, sponsored these jerseys that we have, these awesome live coder jerseys, and as part of that, they were also offering the opportunity to do some technical writing, and so I jumped on it because I thought it would be cool, right? And also like, hey, support the sponsors and all of that, and it has been cool. So far, I got my first assignment. Let's go take a look. Basically, the idea is, given this data set of 10-second clips of YouTube videos where dogs are barking, we want to train a model that can tell whether or not a dog is barking. That's pretty much the short way of going about this here. And the idea is, what are we going to use this for? So really what they want is they want me to build a model that is small enough to then run it on a Raspberry Pi. And I have every intention of doing that, but for now we're just going to get the model like downloaded and trained and built and everything like that, and then we'll figure out how to get on there later. And so my plan here is every time somebody comes to the door at my house, my dogs lose their freaking minds. I mean, they just go completely bananas. And every time somebody runs down my street and the windows are open, my dogs just lose their freaking minds. So the plan is we're going to build a Raspberry Pi that can listen all the time, detect when my dogs are losing their freaking minds, and then play like a dog whistle to calm them down. Or do something like initiate some sort of event to calm them down. And that's the plan. So that's what we're doing. Right now, just to get started, we're going to collect a data set of the audio of all of these clips. I've done a very, 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 very small amount of trying to figure out how to do that. And basically what I found is that they offer trained on a preliminary version of YouTube 8 million. The model used to generate the features is available in the TensorFlow. So basically what we're going to do is there is this repository, which I believe will just go and grab all of these sound clips, convert them into this 128 dimensional audio features extracted at 1 gigahertz. And then for each of these clips, we'll have a 128 dimensional audio features like representation of it, which is great because 128 dimensions is actually quite small. Even if you do like floats, like you're still talking about less than a K per image or per sound per 10-second clip, which is great. That's all we really need. And then the idea is that we just run a really simple model to determine whether or not a dog is barking because we have a bunch of labeled data here, and we move on from there. And that's it. And then really all I care about is running some really basic, like, is it 80% accurate? Is it 70% accurate? Whatever. And then seeing if we can actually get my dogs to trigger it and catch that on video. And that's the whole plan. But today the plan is really just to figure out how to get all of this data. So there is this repo. It's actually the TensorFlow repo. And it comes with all of these, all the code that allegedly you need to, or supposedly you need to actually build it. So what I want to do is clone this and then get to it. Clone. Let's go here. Then we want to go to, I think I'm just going to go clone it straight to here actually. No, we're going to put something in here called, we're going to go back here, say new folder, Content Lab. And then in Content Lab, we're going to say new folder dog bark. And then in here, we're going to clone this. Okay. Clone. And I don't clone with the command line. I clone with a GUI. That's just how I do. All right, once we get this done, we need to fire up an actual Python environment. So probably going to have to update Anaconda here. And I've been using Anaconda on Windows for kind of a long time here. I just don't know of a better way, because I can't even zoom in. I just don't know of a better way to, yeah, let's upgrade. Do I want to download? Yes, I do. Quit, yep. That is in fact what I want to do. Update now. Wow, look how far behind I am. Strong chance this completely fails. Also, strong chance I need to update Python. Okay, so now we have TensorFlow models, which is great. Cannot update Anaconda Navigator. That's awesome. All right. Anaconda Python. Anaconda for Windows installer. Yeah, I think so, right? Yeah, let's download. Let's go open this Anaconda thing, dismiss. Let's see what version I'm actually on here. The first part of every Python project that I do is updating everything. It's awful. I wish there was a better way for me to do this. I don't even know. Like, it's not even like it's Anaconda Navigator. It's not even Anaconda. I don't really know. We're just going to close this and see if this overwrites it. It's probably just going to install something side by side. Yeah, it's just use all users. Okay, so I do have Anaconda 3. Is not empty. Please choose a different location. You know what? We're just going to uninstall Anaconda. Programs. Let's go and remove Anaconda. Just kidding. Uninstall. No telling how many things I am deleting right now that I have no idea what they are. Hey, Clancy, thank you so much for the raid. I really appreciate that. How was your stream? Also, anybody who is joining from Clancy's raid, please tell me what y'all were working on. Fake answers only, please. Hey, thanks for the follow, R2A2. I really appreciate AU. I really appreciate that. It was good, awesome. Peaceful raid. Peaceful raid. Let's get crazy. Let's go to images.google.com. Peaceful raid. These don't look peaceful. Clap alien cheeks. Okay. All right. Well, that was interesting. Not a fake answer. Building a music app. Got the equalizer working. That's awesome. That's super awesome, man. All right. I am trying to collect a data set of dogs barking. And what we're going to do is we're going to build a little ML model that can predict whether or not a sound clip over the last 10 seconds included a dog barking. And if the answer is yes, then we're going to trigger something. Probably something like the whole plan here is that my dogs go completely crazy every time like somebody knocks on the door, or every time somebody like runs by my down my street when the windows are open. And they just lose their freaking minds. I mean, they just go completely bananas. And it's like the whole house gets crazy. My kids start yelling. The cats start losing their mind. And the dogs are just like, yeah, I'm protecting this place, you know? And so I want to make something that when it hears them barking will like trigger something to calm them down, like a dog whistle or I don't know, something like that. And that's the plan. So right now what we're doing is we're grabbing the data set. The data set is actually provided by Google, called audio set, and calls a loop by a knocking door, maybe. And so like, yeah, it's just these 10-second clips. Oh, y'all can't hear what I'm hearing. Hold on. Let's try it again. I might have to restart it to get it. No, there you go. Oh, no, don't play the whole thing. Here we go.
Good girl.
Right, you can see, like, it's super noisy. There was the background noise, there was the human talking. So it's like all of these things are going to be happening in real life. We got to make sure that the model can correctly identify a dog even with those sorts of things going on. And there's like 13, almost 14,000 examples in this data set of dogs barking or making noise of some sort. And so what we want to do is get this, and then there's also a bunch of other things in here that aren't dogs. If we go to like animals, you can see there's like domestic animals, livestock, wild animals, all of these different things, all of these different audio sets. And what we want to do is basically grab as many of the fake examples, or the negative examples, I guess is a better way of saying that. And so we want to have the dogs barking be the positive set, and then we want just random samples of other things going on to be the negative set, so that we can actually do some good discriminatory learning. And that's it. That's the plan. So I went to this site, and it says that all of the models that you need, well, first off, it says that it provides you all of these sound clips as 128 dimensional audio features, which you can grab from this repository right here. So I go to that repository, and it turns out that that's not actually what it does. It's instead the code to go basically generate all of these things. And so what we need to do now, the initial audio set release included 128 dimensional embeddings of each audio set segment produced from a VGG-like audio classification model that was trained on a large YouTube dataset, a preliminary version of what later became YouTube 8 million. We provide a TensorFlow definition of this model, which we call VGG-ish, as well as whatever. And then the idea is you just go and download the parameters, which are these right here. You run this model, and then it goes and grabs all these data sets. I tried out some Sound ML with the new iOS 13 audio classifier feature recently. That is awesome. Let's go take a look. Copy link address. Is this thing on? Oh, that's crazy. That's cool. So these are the same sort of things that are actually in this data set. If you go back and go to the full ontology instead of just looking at the animal ones, you can see there's like human voice, respiratory sounds, ambiguous sounds, sounds of things. This was vehicle engines. There was also keys jangling was one of the ones that was in here. Free sound, copy link address. This is awesome. Free sound audio tagging. Some sounds are distinct and instantly recognizable, like a baby's laugh or a strum of a guitar. Other sounds aren't clear and are difficult to pinpoint. If you close your eyes, you can tell which of the sounds below is a chainsaw versus a blender. Interesting. Okay, that's awesome. Check the data tab. Data. Train.csv. Is this the same thing? No, it's not. There are only 9,400 examples in here. I can't just click it. I gotta... lame. Okay, that's super cool. Audio train, audio test. Yeah, I can't remember. I might have to sign up, but it does have a dedicated set of bark samples. Okay, that's also cool. So, this thing is supposedly... Okay, this is all awesome. I need to finish getting this installed. Let's just hit the button. Oh, shit, I should have read that. Oh, well. We'll see what happens. I want to figure out how to grab... this. Code layout, architecture, output, post-process. A collab showing how to download the model and calculate the embeddings on your own sound data is available here, which is probably what I want to do as well. Because I'm going to want to make it so that, you know, it takes whatever is being recorded by the Raspberry Pi and is sending it into this model, you know, every, I don't know, once a second or something. It would be great if it was just like, here's a giant file to download. Like these. Model checkpoint in TensorFlow checkpoint format. Yeah, I'm gonna have to figure this out. I think ideally I would want all of the actual audio clips as well. So let's go ahead and load this up. Alright, file, close, open folder. I put this in Content Lab, dog bark. I probably want to just open it like this. Models, research, audio set, VGG-ish, readme. Okay, readme, VGG-ish depends on these. All easily available. Easily available. I hope they're easily available. I'm on Windows. Everything says that. Show me what you're doing. Setting up the package cache. Alright. Any reasonably recent version of these packages should work. TensorFlow should be at least version 1.0. We have tested that everything works on Ubuntu and Windows 10. Okay, that's awesome. With Python 3.6.6. So we're just going to do that. In fact, we're just going to do all of this. VGG-ish requires downloading these two data files. Let's go ahead and download those two data files. After downloading these files into the same directory as this README, the installation can be tested by running Python VGG-ish smoke test. You got it. Let's go download these files. Download, show in folder, VGG-ish. cut code. Content lab, dog bark models, research, audio set, VGG-ish, paste. Okay. Let's let Anaconda finish. Oh, unpacking. I see it's actually installing all of these. Great. Perfect. I wonder why it's taking so long. And let's make this bigger. Okay, let's keep reading then. After downloading these, run this smoke test thing. Here's a sample installation and test session. So we'll figure it out. Python VGG-ish smoke test. Usage can be used in two ways as a feature extractor. VGG-ish converts audio input features into semantically meaningful high-level 128-dimensional embedding, which can be fed as input to a downstream classification model. The downstream model can be shallower than usual because the VGG-ish embedding is more semantically compact than raw audio features. So, for example, you could train a classifier for 10 of the audio set classes by using the released embeddings as features. Then you could use that trained classifier with any arbitrary audio input by running the audio through the audio feature extractor and the VGGS model provided here, passing the resulting embedding features as input to your trained model. Inference demo shows how to produce embeddings from arbitrary audio. Okay, perfect. So everything appears to be right here. We're just going to copy as much of this as we can. Perfect. Assuming Anaconda ever finishes installing, we can get started. So, how are y'all doing? Oh crap, you know what else I forgot? I forgot to turn on... Nope, I don't even want this. I don't even want that. Okay. CD. Nope. Cancel you. Close you. Culture of development. Stream chatbot. CD space bin. ls cd space chatbot.cli bin ls cd space debug ls cd space netcore ls. Okay. Chatbot.cli.exe. I forgot about this. Alright. There we go. So what that does, and I missed it already, is it records things like when people follow or when there's a raid or when there's anything else, and then it produces a like template file for my blog. Oh look, it finished. Learn more about Anaconda. Learn how to get started with Anaconda. Nope, okay, we're good. Unpin this. Now, Anaconda. Goodness me, how much stuff do you need to run? Starting to think it did not succeed. Hey, alright. Okay, environments. Hey, it kept my environments too. Everything is going so good. Let's create a new environment called, I don't know, dog bark. We want it to be 3.6.6. I can't specify anymore. You know what? We're just gonna roll with it. And then we need to close this. This is one of the other weird things about Anaconda is if I want to run Visual Studio Code in this environment, I have to start Visual Studio Code from this environment. So now I have a command line with this environment, and now I can say cd spat content lab / dogbark ls, and then I can do code dot, and now we can actually run things in this environment. All right, just to be cool, let's go with version. I don't know, maybe we ought to put the in there. 3.6.9. That's not what I was hoping for. Okay, and then we just have to keep this open. Now we should be able to run the smoke test. So let's run the smoke test, right? VGG-ish smoke. What? CD space models ls CD space research / audio set ls CD space VGG-ish. Okay, VGG-ish smoke test.py. Crap all. No module TensorFlow. Oh, yeah, that's right. Okay, so now we need to go back to this thing where it's like you need all of this stuff. So we need pip install numpy. I guess you can't see that over there, so let me move it. I also don't know how to make this bigger. Okay, numpy installed. Pip install scipy. Isn't there a way to do like more than one at a time? Resampy. Pip install resampy TensorFlow 6 Pi sound file. Conda fix everything. Does that actually work? Is that a thing? Conda fix everything. Fix broken environment. Wow. No, I don't see fix everything. Good one. Installing some. Whoa. It is an opportunity. Sound file 6, TensorFlow, resampy, scipy, numpy, Python. I feel like to use TensorFlow in this instance, we are not going to use excuse me, we are not going to use the GPU since this is eventually going to get installed on a Raspberry Pi. Yeah. This is taking a good long time. It says it installed stuff, but it hasn't completed. So I don't know what it's doing. Oh, okay. There's some more stuff. Hey, alright, alright, alright. Smoke test. No module named TensorFlow. What? TensorFlow. Successfully installed. Python. Import TensorFlow. STF. Now I'm frustrated. Process.exit. No? How do you do this? There it is. Okay. Oh. I just ran VGG-ish smoke test. I think I want to do Python VGG-ish. No module named module TensorFlow has no attribute contrib. So this was trained with TensorFlow 1.3. Okay, so let's drop back to TensorFlow 1.3 because TensorFlow 2.0 is a whole different thing, and this is TensorFlow 2.0. Did I already screw up this environment? Is it going to be like impossible to get rid of TensorFlow now? Probably. I wish they would have included a requirements.txt. That would have made this super easy. Okay. Gonna have to Google this one. Pip drop version. Okay. Install different version of library. Install certain version. Pip uninstall. Pip install. Okay, let's go with a pip list. Oh my god. I honestly feel like I should just create a new environment and start over. TensorFlow. Okay, let's just pip uninstall TensorBoard, TensorFlow, TensorFlow estimator. Yeah, I want you to do that. I do, in fact, want you to do that. Yep, keep on keeping on. Sure. Okay. Pip install TensorFlow. Wait, is it equals? Pip install. Use equals equals and mention the version number. Can y'all read this? Let me zoom in a bit. The version equals equals. Will not overwrite with another version. Use I to ignore previous versions. All right, so equals equals. I think it's that's what we're going to try next. Equals equals TensorFlow 1.3.0. 1.3.0. Okay. I wonder if we should check the versions of these other things. I saw that 6 was 1.12. I'm certain NumPy is up to like 1.17. Who knows what SciPy is at? But probably higher. Even Python was at 3.6.9. If I have to copy it exactly, I'll be more than happy to do that. Okay, let's try this one more time. Python, VGG-ish, smoke test. I'm glad they included a smoke test. Future warning. Passing type. Hey, alright, looks good. Shit, yeah. Okay. Great. Looks good to me. If you see looks good, we're all set. Yeah, that's perfect. Okay, VGG-ish can be used in two ways. Inference demo. Let's open up the README. Inference demo. You could try to train a classifier for 10 of the audio set classes by using the released embeddings as features. Then you could use that trained classifier with an arbitrary input by running the audio through the audio feature extractor and the VGG-ish model provided here, audio extractor. We need to find the audio extractor. Wave file. Okay, so I need wave files. A simple demonstration of running VGG-ish in inference mode. This is intended as a toy example that demonstrates how the various building blocks, feature extraction, model definition, and loading post-processing, work together in an inference context. A wave file assumed to contain signed 16-bit PCM samples is read in, converted into log-mel spectrogram examples, fed into VGG-ish, then raw embedding output is whitened and quantized, and the post-processed embeddings are optionally written in a sequence example to a TF record file using the same format as the embedding features released in audio set. I believe that this file I believe research audio set VGG-ish. Yeah, this is 284 megabytes. That's exceptionally big. Then you have the PCA params. All right, so I need to wrap my head around what all is happening and how to get a hold of the raw files the raw wave files from how to get a hold of the raw wave files from the site. Okay. That was good. I'm going to set this over here so I remember to give that an upvote later. We're going to keep this open. That's good. That's good. I don't need that anymore. Audio set. I don't need 3 of these open. Okay. So, download. The model used to generate the features is available in here. The features were extracted using a VGG-ish inspired thing trained on a preliminary version of YouTube 8 million. Where can I get these 128 dimensional audio features? And in fact, let's just go ahead and see. There are, okay, 2,042,985 times 128 times 128 is 261 megabytes. And unfortunately, this data set, yeah, that's not it. Okay, so that's actually the model. That's not the raw data. So I need the raw data. We offer these in 2. The labels are taken from the ontology. The dataset is made available under Creative Commons. Creative Commons share alike. Okay. This is the CSV. Frame level features are stored as a TensorFlow sequence example. Protocol buffers, a TensorFlow sequence example. Proto is reproduced here in text format. Alright, where can I download this? The total size of the features is 2.4 gigabytes. They are stored in 12,288 TensorFlow record files, shared by the first 2 characters of the YouTube ID and packaged as a tar.gz file. That's what I want. I want this tar.gz file. Here they are. Manually download YouTube corpus EU US. To download the features, you have the following options. Manually download the tar.gz files from 1 depending on the region. Okay. Save link as. Let's put them in my works dataset. Probably workspace. New folder dog bark. So on my machine, I keep an SSD that has, I don't even know how much anymore. Properties. That has like a little less than a terabyte, 930 gigs, which is what I use as my like working space. And this is a very fast SSD. Like one of the whatchamacallums, it's not like the 250 megabyte SSDs, it's like the 1700 megabyte SSDs. I cannot remember for the life of me what it's called. And I want to save this here. Did it work? There it goes. No, that's not done. There's no way that downloaded 2.4 gigs that fast. Or is it just getting started? No, 0 bytes. Okay, open up my workspace. Dog bark. Is that seriously done? No. What? Yeah. Crazy. Okay, so 7-zip extract here. Okay, and then extract here. 7-zip extract here. Destination folder already contains the processed file. Yes to all? Unbalanced train. And there we go. Okay, that's perfect. So now what I need to do, that is awesome. All the files are here. Now what we need to do is figure out how to, if that's a WAV file, TF record file. All right, run a WAV file through the model and also write the embeddings to a TF record file. Sure. The model checkpoint and PCA parameters are explicitly passed in as well. Okay, so what I have is the output of this for all of the files. So I have the 128-bit outputs. Okay, that makes total sense. So that's what this does. Now what I need to do is use those. So I need to download the labels as well. Close this. Let's get the labels. Show in folder. Cut. Let's put it into a workspace. Dog bark. I'm going to put them here. And then let's go ahead and open this up. This is what this looks like right here. Okay, so now I need to figure out what these are. They couldn't make this any more difficult, could they? Like, what in the hell is this? Why didn't they not just put the label name? Oh, wait. I think these... No. class label indices. I think I do want to go ahead and download one more thing. I think I want to download the features dataset. Nope. CSV file format. So I want to download all of these. Download, and download. That one's probably going to take a second. There's dog bark. There's that. And let's just go to documents, downloads. Okay. Balanced, eval, not geonames. Unbalanced. So I'm going to move all these in here. Okay. Okay. So now I think what we have is if we go to this and we're like, open this with Sublime Text and watch it take forever. All right, we have the YouTube ID, the start seconds, the end seconds, and the positive labels. The start seconds, the end seconds, and the positive labels. Okay. Now, if we go to here, how many freaking lines are there in this file? 528? That's not useful. Oh, wait, these are the classes. Class label indices. Okay. So this is the label ID and this is the display name. So let's see if we can find a bark. Bark. So this right here is what we find for a bark. In our data set, there are, let's go back to the ontology. Let's go to animal, domestic, dog, dog. There are 13,705 of these. Let's move this. Let's move something. All right, so now if we go to unbalanced train and we search for this, I am only finding... Oh, wait, no. That was bark. It says there are 2,632 annotations in the data set. This is telling me that there are 2,512. I'm going to guess that this is only in the unbalanced train segments. And if we add 22512 to... We also want to do the eval segments and the balanced... the eval segments. And then here again, we want to search. I really thought there was going to be more. Oh, wait. 60 matches. Okay, well that gets us closer. So we went from 2,512 2 plus 60 is 2,572. Let's look at the balance train segments. So there's another 60. So if we have 60 and 60 is 120, that would be 2632. Okay, that's it. All right, so now we found all of them. All right, all right. Okay. Okay. That's crazy. It's freaking crazy. Okay. So we're going to use the unbalanced train segments, and then we're going to use the eval segments as the other one. We're going to ignore these. Okay, so what I feel like we need to do is take this, YouTube ID, these are the labels for the YouTube ID. All right, let's plan this out a quick second. We're going to use a balanced training set generated entirely from this unbalanced train segments. The way that this is going to work is, first off, I'm going to figure out where the dragger thing is, because it's like right in the middle. Goodness me. Oh, okay, we're all the way at the top now. Okay, so we have these YouTube IDs, and we have the labels. And the only labels that we care about are these ones 05TNY. So we're going to find any row that has this in it, and all we care about is this. All we care about is whether or not it has this in it. And then it becomes true or it becomes false. There's either a dog making noise in this video or there is not a dog making noise in this video. Right. Do we want all the barking sounds? Do we want all the dog sounds? In fact, what is dog? Let's go find dog. Do all of the ones that have... Yeah, I think they do. I think they're all going to end up having... Because it's an ontology, any of the ones that have dog are going to have something else. Maybe that's not true. If 26, that's what, 5K, 6K, 7, 8, 9, almost 10, about 11, 12, 13. Oh, yeah, I'm going to have to add them together. I think so. 18, 26. Oh, you know what? Actually, I can already tell you. No. Okay. 1826 plus 787 plus 3884 plus 838 2363 2632. Okay, so there are a few in here that are just dog and don't have anything else. I guess what we want to do is we want to get this loaded up into Python. We want to build a data set of basically YouTube ID to true or false label. Then what we want to do is figure out how to load up all of the embedding files into memory for the ones that we care about, that we want to do our training on. Then we're going to make a really simple neural network that is just a binary classification network. We're going to, and I probably wouldn't even go super deep on this. I would go like 128, 128, 128, 1. Maybe even just 128, 128, 1. Like, this should be a really simple, super simple, because 128, I might even go like 64, honestly. Times 64. That would be what? All right, this is a nice small model, which is exactly what we want. This is going to end up on a Raspberry Pi. We already have to have that giant 200 megabyte model just to get the embeddings. So I need the classification model to be as small as possible. Okay. All right, let's make a plan. New file. What the hell? Give me a new file. All right, the plan. Okay. Dog bark detection plan. Training. All right, to train this, get unbalanced, set into memory with 2 calls, YouTube ID, and what's the other one? True false label. Oh, don't do that to me, come on. Okay. Make a balanced training set out of this. Great. Train a... Oh, yeah. Load all the tensor something files. Eval tensor record. TF record files for with the embeddings. Only the ones we need. Then once we have all of the training data, we're going to say train a really simple neural network in TensorFlow, like 128 input, 64 hidden, 1 output. Really simple binary classifier neural network in TensorFlow. Okay. And then what do we want to do? Like 128, 64, 64. And then check accuracy. If it's reasonable, if it's greater than 80%, we'll roll with it. Okay. That's it for training. figure out how to do the training in Google App Engine. That's the last step, and that's because it's a requirement of the work that Content Lab wants me to do. They want me to do this training in App Engine for people that don't have the hardware to do it. Okay, then what do we want to do? Then we want to figure out how to get this thing on a Raspberry Pi. Okay. Save model somewhere. Once we're done with the training, get it on a Raspberry Pi. I have no idea how to do this. I have no idea on this one. And we have to wait for the Pi to show up anyway. So we're not going to do that tonight. Alright, ideally what I would like to do tonight is get this unbalanced data set. I'm sorry. Yeah. Get the giant CSV into memory, extract out the YouTube ID, generate the label as true or false. Then I want to make it a balanced set, which is actually really simple. It's just selecting random rows. And then load all of the TF record files. This is the one that I think is going to be the most interesting, but there ought to be a good example of how to do this somewhere. Since there ought to be a good example of how to do it somewhere. That's my short answer. Okay. Training a really simple neural network. There's not that much data that's going to end up going into this. Since there's only 13,000 positive examples, we're only going to have 26,000 total examples. It looks like each sample, so this is a dash dash, and we can see up here, because dash dash would be the very first one, that there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oh no, that's 24. 25, 26. Actually, I just take it in minus 3. Goodness me. These are even smaller than I thought. This can't possibly be right. Are these seriously, like, binary? Holy cow, there it was. Okay, 998. I need to know what the exact size of this file is. Properties. 5960 divided by 996, I think. 5960 divided by 128. What in the hell? I don't know how these are stored. That is my answer. I do not know. I also don't see any dash zeros. Right, that's a dash 0, and I don't see a dash 0 in here. Which makes me really skeptical. Yeah. I'm really skeptical now of how we're going to get a hold of these. Because if this starts with a dash dash, right? Like, let's go take this one for example. This is YouTube / this. No? YouTube. Key and Peele.
Eu não sei.
And then we go to 30 seconds.
Essa força que me leva pra.
That was the whole clip. Let's go to this. Control. Music. Okay, well, actually, sort of that makes sense then, right? Crazy? Okay. Whale vocalization. Let's go hear some whale vocalization. Here's one. What? 270 to 280.
Who wanted to connect
divided
and
by
find
60 is
inspiration
what?
in new places, leading them to discover we're woven together by the moments we share.
260.
Everything you need, all in one place.
Clear.
Expedia.
260 divided by 60. 4.3. No, 270. Clear. 270.
Hello again from the sturdy waters of Aliwal Shoal, a rocky reef based not far from the city of Durban in South Africa.
4.5 minutes.
It is not really a tropical coral reef, and yet
Whale sounds. Yeah, that was serious. Okay. Back to the game. Load these up. All right, let's just do that. Let's install pandas because I think it's going to be the easiest way. I don't know how to do this. Python read CSV. CSV reader. Import CSV. I wonder if it's like... Okay, let's just do it like this. ls cd ... ls. No. I want to go to is it J? ls cd space dog bark ls. Okay, so now what I want to do is say Python import CSV. Okay, all right, we got CSV. All right. We're gonna go with open. I know this is like really small down here. I'm doing my best. I can't figure out how to like zoom in on this. Is there an alt? No, that would have been way too easy. Let me see if there's a better way for me to do this. I need to stay inside of this is the problem. I guess one way that we could do this is not in here, so let's just exit. And then let's go to VS Code, and we can open up, not that, terminal. Go, view, terminal. All right, that's a little bit bigger, right? We can see that. Okay. So now we can go to J. Let's go to Python version. Make sure we're on the same one. Perfect. CD space dog bark ls Python. And then we're going to pull up whatever the example was that I had open. Oh, come on. Okay, just gonna open this like this. Gonna pop that like that. Okay. And we're gonna do the old import CSV with open unbalanced, oh shit, balanced train segments.csv as CSV file, colon, space, read CSV equals CSV dot reader CSV file delimiter equals comma oh, so you got to actually like extract all of the values. I think this is easier with I don't want to do it like this. Import pandas? No. Okay. Pip install pandas. Okay, now let's go and look for that. Pandas read CSV. Oh my God. Just give me an example. There we go. Like it's that easy. Okay, let's try this one more time. Python pandas import pandas. Do whatever you gotta do. Okay. And then we wanted to say var, no, we wanted to say we're just going to say data equals pandas.read CSV of, and then the file name, oh jeez. Let's do one of these easier ones. Let's do eval segments. Errors. Error tokenizing data. C error expected 4 fields on line 4 saw 7. This is... Alright, we need to close some of this shit. We can close that. We don't need that. That's what I need to do for work. That's our plan. Theme to do. I need to save that one. Oh, that's the model for work. We'll probably put that over in the other one. Put that over here. Okay. And then we can say eval segments. It thinks there should be 4 values. Yes, it does. Expected 4 fields in line 4 saw 7. That's quoted. Come on, pandas. Are you seriously that bad? You don't know how to look at quotes? This is silly. Expected for you know what? Let's go like this. Okay, let's save eval segments. Let's try this one more time. Expected 7 fields on line 11, saw 8. This is really, really bad. Come on, Panda's not picking up. Union IO delimiter header names index column use calls squeeze prefix mangle dupe columns dtype engine converters true values false values skip rows skip footer. Okay, let's bring that back. Footer verbose skip blank parse dates infer date time format keep date call date parser day first cache dates iterator chunk size compression thousands decimal. I don't see anything about quotes. I'm wondering if it's like this white space that's causing the problems. Pandas read CSV spaces after commas. Okay. Yes, in most cases for CSV files, Pandas will separate the data by the commas and will keep any spaces that were included before or after a comma. I wonder if we get rid of the spaces, if it'll just figure it out. Hi, Nick. How are you? I'm good. I feel bad for the Falcons. Yeah, it is what it is. Out of curiosity, do you know anything about how to read CSV files in Python? That is what I'm trying to do at this moment. And I'm struggling. Okay. CSV quoted strings. Double quoted elements in CSV can't read with pandas. This will work. It falls back to the Python parser. Oh, look, separator. That's crazy. Let's try it. Okay. Falling back to the Python engine because the C engine does not support regex separators. One car. Let's take a look at that file one more time. So it looks like comma space. So maybe we can just put a comma space here like this. Does that mean we have data then? Oh, we do. Yes, we do. Okay. Okay, I really don't like that though. I would really like to just have it be comma space. Hey, all right, that sort of fixed it. Okay, same data. Okay, let's get a Python file going. What we want to do, I don't want to rewrite over any of this. I want to close this, close this. I want to create a new file in here, and I want to name this come on, 0001 prep data.py. So now we're going to say, what are we going to say here? Exactly what we had down here. Import pandas as PD. Segments equals pd.read CSV, and here we're going to want to put the file unbalanced, right? Yeah, exit ls unbalanced train segments.csv. That's what I'm trying to do. And then we want sep equals comma space. Okay. All right, now that we have the data, now what we want to do, let's go ahead and reload this. What the fuck? Does not support regex. There's no regex. I did not put a regex in there. Is it a regex? Weird. So it just doesn't complain twice? Okay, it just doesn't complain twice. Whatever, I don't actually care. Now what we want to do is figure out what we can do with data. Data.columns. And then what we want to do is say basically we want to select the ID, and then we want to select a new one. Okay, let's figure out how to add a new column. Save this one so I can upload it later. Pandas, create new column. Adding new column to existing data frame in pandas. pd.series 2015. Some reported getting the setting with copy warning with this code. Edit 2017. DF, as indicated by the comments, currently the best method to add values of a series as a new column of a data frame could be using the assign. Okay, sounds easy enough. Now the other thing that we want to do is say run a regex against all of the values of a series. Okay, let's do this. Let's do data dot positive labels. Okay, and then what we want to do is run this through a regex. Python regex pandas column. Applying a regex to a pandas data frame. Apply season. Where's the regex part? Regex.find all. Breaking up a string into columns. Replace values in a panda data frame using regex. Okay. Data frame, you got a city. You have event. You have cost. Great. df.replace. Don't do that. Sorry, Geeks for Geeks, don't do that. Regex. Okay. Pandas. All right, pandas. Get all rows that match regex. How to filter rows in pandas by regex. Really what I want is like a true or a false. Foo is a data frame. The column name is b dot string dot match. Okay. What in the hell? This broke. That's not good. There we go. Dot string dot match. And then what we want is basically do I want match? Oh yeah, contains. There you go. That's exactly what I want. String contains. Okay. And now what I want to do here. What the hell? Look at that. Okay, so I just want to do a contains. That's great. That is absolutely great. And then I want this and the labels, and I want dog. Okay, perfect. So now I want contains. Perfect. And then I want to say data.assign is dog equals that. Okay. All right, all right, all right, all right. And then I want df, not df, it's not df, it's data, where data dot is dog. Oh, what the fuck? That should work. Shouldn't it? I want all the rows and I want all the columns. Fuck. Oh, that's right. That's right, right. Wait, no, data. What the hell? Oh, that's weird. Oh, yeah. Okay. That's right. So this creates a new one. You have to set it equal to it. Boom. Now, I can say that. Actually, I think I can just do that. Yes. 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 Why is there only 230? Because this is unbalanced train segments, which should be huge. Why is there only 230? That's not right. That's not right. Let's do data string dot contains dot sum. Shit. Why is it telling me there's only 230 of these? That's not right. Is it? That's not right. How many should it be telling me? In this data set, data, there's 20,000 rows. Actually, 20,000 rows is quite small. Unbalanced train segments? What the hell did I do? What did I load? Oh, I did eval segments. Okay. Unbalanced train segments. Yeah, that's much larger. Then we had segments equal segments dot assigned is dog equals segments dot, the hell was this? Positive labels dot string dot contains that. Okay, now we should be able to do data dot is dog. Frick. Nope, you gotta add it in there. Data equals data dot assigned. Positive labels. The fuck? It does have positive labels. Am I losing my mind? I am losing my mind. Okay. Data equals data dot assigned. No, just data dot positive labels. What do you mean? I have got to be losing my mind. Oh, I gotta skip 2. Skip lines equal 2. Okay, let's go find what that parameter was. Pandas read CSV skip lines. Skip rows. Skip rows 2. Skip rows 2. I've been nursing this beer for like an hour and 40 minutes. I'm going to have to wrap this one up and get another one. This was my very first homebrew. It's actually pretty clear, all things considered. Okay, let's take a look at this. Data. All right, this time it's better. Now there ought to be data.positive labels. Perfect. Okay, the only problem now is the hash mark at the beginning of this. It's kind of silly. So I think we want to set the names. I think you can just do data.columns equals ID of start, stop, labels. Okay, categories. Ooh, that worked. All right, let's do that. Segments.columns equals categories. Then we want label equals this. So now data equals data dot assign label equals data dot categories dot string dot contains slash m slash 0 bt 9lr. Perfect. Yes. And then we can say data.label.sum. All right, and we have 13202. Okay, so now we actually have a bunch of labels. Perfect. Now I want to subtract out only those two things. Segments equals segments, and we want 2 columns, ID and label. Okay. Data, ID, label. Perfect. And that's exactly what we want. Like, that's the output. Okay. All right, clean up the input to be sample ID label. Okay, that takes care of this part. Our dog bark detection plan with 2 columns. All right, make a balanced training set out of this. All right. What we want to do is say positives, samples, okay, pandas random rows. Sample in. Yep. Positive samples equals segments dot label. Negative samples equals segments not segments dot label dot sample in. Can I do it like that? Yeah, in equals ln of positive samples. All right, can I do this now? Oh shit. Import pandas as PD. Okay. Perfect. Perfect. Oh. Yeah, that's not positive labels, that's categories. Okay, then we want to select just these. Now we want to say positive samples. Now we want to say ln of positive samples. Yeah, that's exactly right. We want to say negative samples. Ooh. The truth value of a series is ambiguous. What? Segments.label. Dot bool. Not. What the fuck? Okay. So I want to take the negation. I want to take the negation of a. Okay, pandas. Negate series. The element-wise logical knot of a panda series. Yeah, that's exactly what I want. Use. Not S. That is absolutely, unquestionably not obvious. Holy Jesus. That is also such a small little thing. Okay. Alright, now we have negative samples. So now what we should have is ln of negative samples. And then what we want to do is say training equals. Somehow I want to concat these. Row bind. Pandas. Actually, I need to save that one for upvoting later. Pandas row bind. Append? Append. Ignore index. If you're creating a frame using a loop statement and a statement that looks like this, you must ignore the index. Sure, let's give that a shot. Equals positive sample dot ID. Okay, positive samples dot append negative samples dot ID. Hey, all right, I kind of like that. And then I want to say I sort of want to like order these. If I want to grab them by the index, if I want to take them by the index, I think we just do dot index. And then I want to say we can do sorted. And then I want to say we can do training equals segments of this. This cannot be the best way to go about this. It can't. I just know that to be true, but I'm just not going to worry about it. Oh, God. Select by index. Select by row index. Pandas. Subset by row index. Oh, iloc. Row numbers. Label or conditional statement. I would buy row numbers. iloc. Training. Hey, all right. Okay, that's our training set. That one was good. Okay, that's our training set. Make a balanced training set out of this. Load all the TF record files with the embeddings. Only the ones we need. Okay, it's been right at 2 hours. I'm going to take like a 3-minute break to go to the restroom and grab a beer, stand up and walk around. Hopefully I will see y'all in just a few minutes. Thanks for hanging out so far. We're sort of getting to the fun part now. We're going to actually load in the data that's going to go into training the model, and then we're going to put together a really, really simple model just to see what happens. We should be able to get through all of that tonight. I don't know how long it's going to actually take to train it, but 30,000 samples of 128 is like smaller than MNIST. It shouldn't take that long. So we'll be back. I'll be back in about 5 minutes. All right, let's get back to it. Okay, let's get back to it. Woo! Load all the TF record files with the embeddings. How are we going to do that? Okay, so in the files, if we go to models and we go to research and we go to this, somewhere, Google Crash Handler? What the hell? Who knows? VG-ish inference demo shows how to produce these. That's not really what I want to do. I want to find something that stores a TF. Okay, let's do a find on TF record. TF record. TF record. Okay. TF record. Come on. Wow, this is in here a shitload. You know what? I'm not looking in the right thing. I'm not looking in the right thing. I need to limit this. Files to include VG-ish VGG-ish star. Okay. TF record file, Control F. TF record writer. Control F. Writer.write. Okay. TF record reader. Okay. TF record reader. That's not really what I want. Okay. Reader.read. Sequence key, serialized record. Let's go VGG. Okay. Writer. Sequence example dot serialized to string. Well, that's interesting. So that means these are strings. Negative. Okay. TF record. Sequence example. I think train demo. Smoke test. Train demo or smoke test? Train demo. This is intended as a toy example that demonstrates how to use VGG-ish model definition within a larger model that adds more layers on top and then train the larger model. If you let VGG-ish train as well, then this allows you to fine-tune the VGGS model parameters for your application. If you don't let it train, then you use the feature extractor and the layers above it. Okay, sure. Distinguish three classes: sine waves, constant waves, and white noise. We generate synthetic waveforms of each of the classes, convert it to shuffled batches, and feed the batches into the model that includes this. Okay. What is VGG-ish input? Input. Okay. Waveform to examples. Okay. Wave file. Waveform to examples. Where the hell is this? Waveform to examples. Okay. Data. Make a spectrogram. Wave file to examples, waveform to examples. Got it. Audio embedding feature name. Okay. So I need to figure out how to read those giant, humongous files. Which is not in here. It's in here. No? How did we get to the audio set? It was here. We went to download. We were like, the features data set is right here. Okay. And then frame level features are stored as a TensorFlow.sequenceExample protocol buffers. A TensorFlow.sequenceExample proto is reproduced here in text format. Okay, so I need to load a sequence example. Sure. How do I load a sequence example? That's the question now. And then once I load for embedding and processed batch, embedding batch, okay, so it just generates some random ass wave file. And then it's like, here's my TF record writer. And you have a sequence example. Video ID. Audio embedding. Params. Audio embedding. Audio embedding. Okay. That's not what I wanted at all. Okay, audio embedding. That's weird, it has it twice. Repeated for every second of the segment. Ah. Okay. So I need to figure out how to read this in. Okay. Let's go like this. Let's go bring up. Nope, not this one. Give me view. Terminal. And then I want to say import tensor flow as TF. Oh, that looked awful. Yeah, whatever. You do what you need to do. Okay, now we can say reader equals tf.record reader. File queue. I don't know. TF record reader. Okay. No, that one's not good. File queue. Imnist. Reader. Data sources. File pattern. Slim.dataset. I don't know the answer there. Reader. I don't even know. Read. String input producer. I don't know how to read these in. So we're just going to try it. tf.gfile.glob. Okay. We're just going to do that worked. File names equal tf.g file.glob data file pattern. I think we're just going to point at this directory. And we're on Windows. /star.tfrecord. File names? Hey, shit. Alright, that's kind of cool. Did you see that? It just worked. Okay, so we got some file names. Alright, alright. File name Q. equals tf dot train dot string input producer file names. I'm not even going to worry about shuffle. Alright, we got a file name Q. Keys examples equals reader dot read file name Q. Now, what the fuck? A tensor. Examples? I don't know what to do with this. TF dot parse single sequence. I think the feature spec here. Okay, we can make some progress here. Feature sep equals, and this is called, the hell was it trying to save it as here? Audio embedding. Whoops. Audio embedding. And then I need to come back up here and go, yeah. TF.fixed length sequence feature. I don't know. I don't know how to read these in. Yeah, I don't know how to read these in. I understand that frame level features are stored as these, but I have no example on how to load this. Released in audio set. Each row of the batch of embeddings corresponds to roughly a second of audio. Sequence of bytes valued feature where each feature value contains the 128 bytes of the whitened quantized embedding. Hmm. I'm not really sure. I'm not really sure how to load this. Okay. Um, I'm not going to dig into this. No idea what you're doing, but I'm about to fall asleep to it. Well, I'm glad I could help with something. I am trying to figure out how to load a bunch of data from some audio files that I downloaded into 1,444 items. And honestly, I think there should be like a shitload more of these. I think there's supposed to be like 12,000 of these files, and I don't know where the rest of them are. Have to go figure that out. Oh wait, no, they're in here. Yes, here's where they are. Okay, so they're all in here. Well, I guess there's only 1,444. And I need to... What do I need to do? I need to figure out what the format of these files are and how to load them, and then figure out how to get all of these features into memory. I think that's what I need to do. Models and supporting code is available here, along with the supporting code for audio feature generation, embedding, post-processing, and demonstrations of the model in inference and training modes. Alright, so there's some starter code here. Oh my god. Released the... Way beyond my level. I'm just trying to program tic-tac-toe AI. Well, that's fun. I was actually doing that the other day. You want to take a look at it real fast? Let me save all this real fast. And then, yeah, let's go ahead and just open up the other one, which was Monte Carlo tree search. There we go. So this is, I think we can just ls cd space source, ls cd space mcts, ls, yeah, .NET run. Oh, that's right. Yeah, debugging test, play game. And this is going to be, we will have us play a Monte Carlo player. Okay, perfect. Alright, the way that this works is it gives you all of the possible boards that you can play. You choose 0, you end up with this board. You play 1, you end up with this board. You play 2, you end up with this board. Right? That's the plan here. So let's play 3. And you'll notice that we played 3. So we ended up with this board. And then the game thought about it. And the game decided that it's a tie if it plays here. And everywhere else it didn't do nearly as well. So it decided it was going to play here. And go for the tie. And now it's our turn to choose again. And actually, this looks like a win for us. How could it possibly think that's a tie? If we play here, it's forced to play here. Oh no, we can't play. Yeah, because we'd have to play there. Yeah, okay, that's a tie. If we play here, it has to play here. Oh no, it's a win for us. Weird. How does it think that that's a tie? Because all we have to do is play in the middle. It's forced to play here. We play down here, and we now win diagonal, and we now win vertical. So it should lose. Okay, let's do that. Let's play in the middle. We're going to play 3. And it decided to just straight up lose. Alright, this is the bug that we were working on. It's not a bug. It's not really a bug. So what happens is it plays some spot and it thinks, oh god, I'm going to lose. And it thinks it's going to lose 100% of the time. And it does this for all of these moves, and then it plays some move that is actually a loss, but randomly it wins when it plays there because it's just playing completely raw random games the whole way out. And so what happens is it thinks this guaranteed loss position is the only one that has any chance of winning whatsoever, so it keeps trying it, and then it goes ahead and it plays it. It's not really a bug, it's just a really poor way to do the evaluation. My semester is going well and I have all A's and I'm enjoying what I'm learning so far in college while also building good relationships with my professors. That's great, Drew Cooper's son. That's awesome. I'm really glad to hear that. What classes are you taking? So the trick of this that we were working on last Friday is that this is what's called pure Monte Carlo, and it gets itself into these really like latched ass side cases where it just thinks this is an awful move, and this one is the only one that has some modicum of a chance of winning, so it plays that one. And then what happens is what we need to do is change the exploration strategy. This should never get to 995. And us think that like 1.5 out of 995 is better than 0 out of 1. Because we haven't played this one very much. So what if we played this 3 more times and we won one? Then this would all of a sudden have a 25% chance of winning instead of a literally less than 1% chance of winning. And so at some point you just need to explore ones that you think are worse and play them again. I'm trying to hard code the moves. That's also a valid way to go. In fact, tic-tac-toe is one of those games where you can just learn the moves outright, the absolute best moves for any board. I think I worked it out once. There's like 19,000 and change boards that you can play. And like if you store a, let's call it an integer for each one that tells you where to play next, that's like literally less than 20 kilobytes of memory you need to play perfectly by just looking at a lookup table. And the way that I would build that lookup table is by just playing a raw Minimax. Minimax can solve this game no problem. There's only, it would solve the whole game in under a second for sure. And then you just output every single terminal position as like the key in a dictionary, and then you output the move, or I'm sorry, every single possible position, and then you output the optimal move that comes after that. Yeah, hard coding it. Actually, hard coding it might be kind of difficult. Unless you just looked for any single win and tried to block any single win or tried to play in any spot that would give you a guaranteed win. But honestly, it'd be less code to just write a minimax. A minimax is like 8 lines of code. Intro to object-oriented programming with linked lists and at the end discrete math. Only if my Bears were doing well would I be happy. Well, they might still do well. It's early in the season. We're only about halfway done, and they've been dealing with injuries, so I'm sure they'll get back on track. Yeah. You know, I think there's, like I said, I think there's 19,000 possible states. Trubinsky shows signs of regression. Yeah, maybe. Maybe. Football's hard. I mean, they got the defense. Defense will keep them in the games. They really only need to score like 20 points a game on average. They'll be fine. And not only that, who else is in that division? They got, oh no, they got to deal with the Packers. Yeah, that one's not easy. The Packers are having a good year. Who else? Is it NFC? I don't know. What was your hardest CS class as an undergrad? It was a class called Math Models for Computer Science. I failed it twice. I dropped it one time. And I finally got a B on my 4th attempt. And this class had nothing to do with writing software. Yeah, it was a required class. I didn't have a choice. At my program, this was like one of the 4 math classes that was absolute. Well, I guess one of the 5 math classes